Let's now take a look at how we can utilize what we have discussed earlier to price interest rate derivatives. First of all, we're gonna um, to discuss how we can determine the interest rate term structure out of the short rate process. Then we're gonna talk about how we can price options once the interest rate term structures are determined. There are two main types of short rate models. One is called the equilibrium models, and the other type is called the no arbitrage models. Now, the equilibrium models are usually derived out of economic theories. So they are the endogenous process as a result of market equilibrium. Basically, if you laid out the fundamentals of economic theory and you basically build an entire economy there, how the production is going to be like, what is the endowment of this economy, what's the technology in the economy, and you look at everything within the economy, then from that, and you use economic theory to determine what process that instantaneous interest rate must follow within that economy. And that process is what we call the equilibrium model. So it's a process that's been determined with a modeled economy under equilibrium. And so if you learn economic theory, you will actually be in touch with a number of the equilibrium models. Now there are three main ones. One is the Randleman and Barter. So this is basically a log normal process for interest rate, instantaneous short rate. And I have a bracket here that says no mean reversion. Now, mean reversion is a very key aspect of interest rate. So if you look at stock price, the stock price can go anywhere. They can go as high as you want, will never actually get to a particular level. But for interest rate, you don't see interest rate going up to like 100%, 200%. If you do see that, then very quickly the whole economy is going to be in crumbles and you have hyperinflation. So you really then the whole economy is going to collapse and they will reintroduce a different ones and they have to change the currency and so on. So interest rate of 100%, 200%, 300% is not really sustainable. What is sustainable is some level of interest rate that that would not cause hyperinflation. So over the long run, if the economy survives and stable, you do see that there's a sort of a long range interest rate that the economy will gravitate towards. It can be higher than that temporarily, and it can be lower than that temporarily. But if the economy were to survive over a long period of time, it should be right around that long-term rate. Okay, cannot depart so substantially away from that, and so therefore the long-term level of that interest rate we call the just an interest rate target there, and if it's very much higher than that, over time will tend to go lower towards that long-term rate. And if the current rate is substantially or relatively lower than that long-term rate, you will see that over time the interest rate will actually go up to that long-term rate. And that long-term rate has something to do with the rate of the economic growth. So how much of GDP can grow. So if your GDP is growing that at 3%, it's very hard to sustain an economy that is having an interest rate of 10% and higher. So if you are at 10%, over time you will actually start to go lower. So the long-term interest rate has something to do with the growth rate of the economy. Now, if you have a mean reversion model, then it's desirable. So Vassilchak model is a mean reversion model. So here, the long-term interest rate is this B. So if B is higher than the current interest rate, short rate R, then there's a pull, right? So this part becomes positive. So there's a positive drift. So that instantaneous interest rate will tend to go higher over time. If B is lower than R, so the long-term stable instantaneous rate is lower than the current rate, then this part is negative, and that means the interest rate would tend to be lower. So if the long-term interest rate is lower than the current rate, then this first part will be negative, and then the current interest rate will go lower. Okay, to chase after this long-term rate. And this A here is what we call a mean reversion speed. It determines how fast, if there's a difference between the two, how fast the interest rate will move to catch up. Now, the problem with Vassilchak's model is that it can actually give out negative interest rate. Whereas if you look at this Randleman and Barter one, because it's a log normal process, interest rate will never be negative, but interest rate could be negative under Vassilchak, which is not something totally impossible, but like hyperinflation, negative interest rate is probably not something sustainable for a long period of time. And so we have this Cost-Ingersoll and Ross model, CIR, and where basically that incorporates mean reversion here. And also because of this square root process, then interest rate would not be negative, would never be negative under this process here. So instantaneous interest rate would never become negative under the CIR model. However, CIR model is substantially more complicated than the first two. And so we don't have normal distribution, log normal distribution anymore. Here with CIR, you would require a non-central chi-square distribution.